Okay, well, thank you everyone for joining us today. Welcome. We are about to dive into our webinar on predicting outage duration with machine learning. My name is Tomer Borenstein. I am the CTO and co-founder at BlastPoint. And here on the webinar with me is also Jackie Robinson, Director of Customer Experience at DTE. Jackie, thank you so much for taking the time to hop on this webinar with us.
Absolutely. Thanks for having me.
Awesome. So today we'll talk about using machine learning to improve estimated time to restorations, or ETRs. We'll talk about why it's so important for utilities, why it's such a hard problem to solve, how utilities can leverage AI to improve their ETR accuracy, and what we've been doing together with BlastPoint and Jackie's team at DTE around this topic. So, let's start with the results real quickly, just to kind of flash, the end result here, and then we'll take a step back and talk about how we got there. So still a work in progress, but so far we have been able to double the original model's performance, and we've also been able to pull ETRs forward by 4 hours at DTE without losing any kind of accuracy. So, Jackie, I'm wondering if we can get started by talking about why this is such an important topic for DTE, and maybe we can start, with the summer of storms.
Yes, absolutely. So I've shared the story with Tomer when we started to work together, but back in 2021, we had what we describe as the summer of storms. And pretty much from June 20th until September, actually almost into October, I worked every single day, and a lot of people at DT worked every single day, either being in storm, preparing for storm, or cleaning up post-storm. So we had back-to-back storms with several very large catastrophic storms involved, and just was a terrible time for our customers. And during that time, we also found that we found the defects that we had in our customer communications, defects that they've always been there, but when you went through that many periods of storms and outages and everything, just really, they were really amplified. So for example, we were telling people their power was on when their power was still off. We were telling people that their had been restored when they hadn't been restored. Just really a lot of defects. And in addition, our ability to get estimates out the door in a timely manner was not good. We had many hours where we were analyzing data and trying to get estimates to our customers, and really just we were not accurate at all, maybe a 30% accuracy rate, and it took us a long time. So what this caused was basically the whole area was actually up in arms about the performance of DT and our reliability and our ability to communicate. And during that time, it was also a election year. So we had several people that became a bit of their platform. They couldn't control everything, but they could, put pressure on DTE. So it created a really bad political landscape for us. And when those people, were causing some of these discussions about DTE, it also started to affect how our regulator, the Michigan Public Service Commission, felt about us and worked with us. And when that happens, that really affects our ability to get successful rate cases and work successfully with our regulators for a good climate. In addition, public perception and trust, people were not trusting DT. We couldn't get any of our information right. When you're communicating misinformation or didn't appear that we really understood the situation at people's houses, we lost trust completely. And our customer satisfaction scores just really showed that. And, at that point, we really just couldn't blame our customers either. They were having poor reliability and they were not getting good communication.
Yep. So it was sort of the perfect storm.
Yes.
And why we really needed to get this project off the ground. And Jackie, you mentioned the effect on CSAT, so I do want to take a minute and talk about the impact of outages on customer satisfaction overall. So obviously there's everything else you talked about, but BlastPoint is a customer AI platform for utilities, and we're being used by utilities to drive engagement and improve satisfactions. So one of the things that our platform has built in is this special machine learning model that scores customer satisfaction and NPS scores at the household level in real time. And these models tell us which customers are dissatisfied and for what reasons. And when we're looking at the insides of these models to tell us what are the biggest drivers of CSAT, both positive and negative, they show that outages right after collections end up being the largest negative driver for CSAT and NPS. But the things that we've sort of learned over the last year or two and through discussions with you guys is that while outages are a huge driver of negative CSAT and NPS, they're also an opportunity to build loyalty and trust if you do things right and engage and communicate with your customers in a way that is reliable and accurate. So Jackie, is that something that you guys have seen in terms of it also being an opportunity to build trust?
Absolutely. And I will say we've seen this in our NPS scores. So when we have a period of outages or we have a certain community that's affected by outages, it absolutely has a shadow effect on all of our other transactions. So you can have the most perfect payment transaction or move in, move out transaction. But if you have a poor outage experience, that affects all those other transactions. So we've seen when we have a big storm, we see all of our satisfaction scores dip, not just in that area, not just in the outage area, but everything. It has a shadow effect. And then, yes, absolutely. We found that if you can actually communicate effectively with customers during an outage, they're not happy about it, but they at least see that you're trying and that you understand the situation. So for example, we call it our moments of truth. If you could tell somebody, yep, we know you're out, here's your estimate, if you hit the estimate, and then you can tell people they're restored, it positively affects their outage experience.
Cool. And Jackie, this is research from Chartwell. Wondered if you had anything to add here in terms of the kind of information that customers are looking for during an outage and why. I mean, obviously, I think the slide kind of tells its own story.
Yeah.
Why did we go with ETR being the thing that we're trying to communicate?
Yeah, absolutely. ETR, this one says king of outage information, the holy grail, however you want to describe it. But basically customers, they want to hear what their estimate is going to be so they can plan their life. They need to know, is it tomorrow? So I need to go find a hotel room if it's really hot. It's today? It's going to be just, a couple of hours of inconvenience. So yeah, customers absolutely need to know what a good estimate is so they can plan their life. The other areas are also, something that they would like to know, but frankly, it's all about the estimate.
Yep, it's that bottom line for the customer. Like, when am I going to be able to move on with my life?
Exactly. So yeah, so other reasons. So absolutely, we talked about customers really need to know, their individual estimate. So that's super important. There's also this aspect of emergency preparedness and public safety. So, there's certain areas like hospitals, or if there's certain individuals that, that need extra care, it's really important to have an estimate for those people. In addition, I mean, I kind of always think about people and, individual, but there's also businesses. Businesses need to know what their estimate is. They need to know, do they close up shop today and send everybody home? Do they need to bring in extra resources to protect, perhaps something, refrigerated goods? So they need to be able to plan for, their business. So that's another really important reason why we need good estimates.
Yeah, so it goes beyond just customer satisfaction, which obviously is something that we care about as a utility that serves a vertical slice of society, but also, it's not just about satisfaction, it's, there's an economic impact, and there's a life or death component here as well with some of these organizations and businesses and institutions that are relying on having this reliable power. And otherwise, if the power is out, being able to plan around that and make the decisions that they need to make in order to continue operating for the duration of the outage. So let's talk real quickly about one of the reasons why this is such a hard problem to solve. And that reason is the tension between overestimating and underestimating ETRs, right? So on the one hand, you definitely don't want to underestimate, telling people that their power will be back by a certain time, and then it's that time and the power is still out. And the most annoying thing is when you're being told it's half an hour, and then it's another half an hour when it's
Exactly.
when the half an hour is done, and then it's another half an hour. There is that great episode of 30 Rock where they're all on a flight and they keep getting that half an hour until the entire plane goes crazy. So, definitely, we don't want to underestimate. So you would think maybe the strategy should be to always overestimate, which means under promise, but over deliver. But in reality, while that's better than underestimating, overestimating also has a negative impact on customer trust too. So I'll give you an example. I am, a First Energy customer, and actually I think First Energy has some great pre-outage communications. They knew that I was going to be out well in advance and all that stuff. And then the day of the outage happens, and we're being told it'll be 3 days without power. And, I guess despite those early communications, I didn't open my email on time. I just went grocery shopping and filled my fridge with about $200 worth of groceries. And we were told, oh, you're not going to have power for 3 days. And we, my wife and I didn't want us to just let everything just sit in the fridge and go bad. So we threw a bunch of that food out. And about half an hour after we finished throwing it all out and we tied the trash bag and put it outside, the power came back on. And our first thought wasn't, oh, thank God, because we can get back to our life. It was, oh my God, we just threw away $200 of groceries. So Jackie, is this something that you guys have seen when you were doing research about what kind of window we're looking at and what kind of accuracy we need to hit with these ETRs?
Yeah, absolutely. So I know a lot of people think, let's just pad the estimate, make it so that, be conservative. And then, if we restore early, they'll be happy. And just from your story, there's countless, I read a lot of the NPS verbatims too. I see it all the time. You said I wasn't going to be on until 8 o'clock at night. So I've been sitting in Starbucks so I could get some Wi-Fi for 8 hours. And if you would have just told me, I could have gone home. Or people that, they got a hotel room for a couple nights because you told me Thursday and it's Monday. I don't want to sit in a hot house, or any number of different things. So yes, we absolutely, a late estimate's only 15 minutes past. And we give ourselves a little bit of flexibility in early estimate. I think we can restore up to either half an hour or an hour before the estimate, but it's not like hours, right? It's a pretty tight window that you can restore early. So yeah, yep. We're working from both sides. We want to try to get that right, get it accurate, frankly.
Yep, for sure. And here are some additional research from Chartwell that shows that customers will not tolerate late restoration, but they will tolerate early restoration. But I think the key word here is tolerate. It's not like they're super excited about it. They'll so, we're about to go into more about how we solve this or are solving this with our BlastPoint DTE partnership. And, for everyone listening, the good news is that AI and machine learning can help utilities address this. But before we dive into the performance of the models that we've built so far and some of the strategies that we employed, and we'll try to cover the gamut of non-technical as well as maybe just a little technical to to give the technical folks, some information as well. But can you actually walk us through the process that DTE uses right now without a model to estimate ETRs? Because I think that's really important when we're trying to use machine learning to simulate a process that is, starts as a human process. Let's talk about what that process looks like.
Absolutely. So, and I should say that, I'm speaking for DTE's method. I know a lot of utilities use similar paths, and I should say most of us are all believing that, ETR is king and the holy grail. It's the industry-wide problem that we're trying to solve. So what we do is when we have an event, so right now during blue sky, so that's without storms, just a regular weather day, our outage management system does an okay job of predicting what the estimate should be based on, historical data. What we were really suffering, like lack of a tool, is during weather events. So we have storms and we have catastrophic storms, and it just depends upon the size and the number of people that are out. And what we have a role called an estimate manager, and they get activated when we start to see weather come in. And they basically do, a rough model on Excel, basically. How many crews do we have? How many outages do we have? They kind of look at how many wire downs we have. And frankly, I think, Tomer, you and I have talked about this before. They're running like a model in their head, right? Using all of their historical knowledge and, pulling together, well, the last time we had a storm this big and, the damage assessment out in, is not that bad, or the reverse, we've had, lots of down wires, poles, etc. And then they come up with like a methodology. And, they use the similar methodology where big circuits are first, right? You try to get as many people back as fast as possible. So put your resources on the big ones and then keep marching down. And so, as I kept, learning more about the process and digging into things, in my mind, that's what these really smart people were doing, was a model. So we started to develop a model at DTE based off of that. We have some really smart data scientists at DT as well. So we started to build a model, but it was really like a part-time job kind of thing for some people. But yeah, that's the process. They're basically some estimate managers. They bring together some data points that they get. And frankly, we were talking about timeliness here a lot. This was a process that, could take, in Michigan, it feels like all of our storms come in at night, right? So come through like 8 o'clock at night. Can't do much about the damage and things by once we lose daylight. So what happens was the estimate methodology would be put together, and people, kind of overnight, it's a dead zone. So people, they might have went out at 8 o'clock the night before, but they're not getting their estimate till like noon, sometimes even the next day if it was a really big storm. And that's just crazy. I mean, we knew people are just like, get us an estimate. And the only way, so let me step back. We've been trying harder at that process for a long time. Like, let's get better damage assessment. And it just, the timeliness was never going to work, right? So that's why we turned to using AI and using a model.
Yeah, it's not like these people are getting their power cut off at 8 p.m. and then they're going to sleep like it's all good, and they'll check in on it tomorrow morning, especially during storm conditions. So great. I think, with that in mind, we can really, think about how do we take this process that right now is manually estimated and start to use data and AI to automate that, improve the accuracy, and maybe even make some associations that humans are not able to, and use those associations to do an even better job. And, like you mentioned, DTE had a baseline model when BlastPoint started working with you. We've been able to double the accuracy of that baseline model, and we've been able to, pull forward the estimates at the same degree of accuracy of DTE's process by 4 hours. And, I think that 4 hours is really significant, because one of the things that you shared with me is that according to some of the research that you guys have done, customers really expect estimates within 30 minutes during blue sky conditions. And we've got about 4 hours within storm conditions. So this is exactly, you know, that window that we were able to pull those accurate ETRs forward by. And so, you know, the BlastPoint machine learning piece is one piece of the puzzle, and I'm about to dive into more technical nitty-gritty details of what that model looks like under the hood. But I did want to take a moment to talk about the holistic approach that you guys at DT are taking towards improving your outage communications. You call it Outage 2.0. Can you tell us a little bit about, you know, the overall project, and then we'll dive into the machine learning piece that we've been involved with?
Sure. So back at the Summer of Storms, we actually kicked off a program called Error-Free Communications. And it was, the goal was to provide customers with accuracy around, you know, their moments of truth. So, and I said it earlier, it's about, you know, letting them know, hey, we know your power's out. Here's your estimate, and your power is restored. And everybody always thinks that last one is so, well, of course they, you know, they're sitting in their house, they know their light's on. No, a lot of people actually aren't sitting in their house when their power is restored because they've decided to go someplace else. So we kicked off the Error-Free Communications program back after the Summer of Storms, and we've been marching down a path to improve the accuracy of our outage communications. Made some great strides in some of the outage, the bookends moments of truth with power out and power restored. Did some new notifications for customers, expanded our notification reach, even put a new platform in. But really our estimate piece is the one we're still trying the hardest, the place we're working.
Yep.
So we've made some great progress on our outage communications. The area that we're still struggling with is around estimates. And that's why we engaged with you guys last year to help us with our estimate accuracy. But it's not just about the model. So we've also really had to change our culture around estimates. There's a lot of people in the operations organization that their job is they just want to get the lights back on, and the estimates, you know, important to them, but they're like, I'm just trying to get the work done. So we've had to stress the importance of how important it is to have an accurate estimate for customers and try to change the culture there. We've added some additional roles that we have estimate managers now that are at the service center levels so that they are able to track those a little closer and can be in contact with crews when we're coming up to an estimate. So we've had some roles. In addition, we've done some process improvements on how we execute estimates. And I think one of the other important areas that we've really gotten involved in is on just measuring, which seems ridiculous, but before we really had this project, we didn't have good dashboards and measurements. In fact, I told you many times, we actually said that we were like 90% accurate with our estimates. And, you know, when you start to see the customer's feedback, you're like, how could we be that accurate? And so when we dove into it, we were measuring ourselves accuracy against the last estimate that we gave the customer. So we might have changed your estimate 3 times, but if we hit that last one, we were accurate. So, I mean, that's actually been, you know, you can't measure, if you can't measure something, you can't improve it, that kind of theory. And so that's been some of the other area of work we've done.
That's interesting. It reminds me of this tidbit of information that I listened to on a podcast once, that the most accurate pollsters, like during political campaigns and make predictions about who's going to win, the #1 predictor in how accurate someone is how often they change their predictions. But obviously not something that you can do,
Yeah.
not something that you can do in this situation. And, you know, something, you know, I wanted to make sure that we talk about the entire Outage 2.0 program at DTE, because, you know, when we visited and started working with you guys, that was something that I was really impressed by. It really took this well beyond just a machine learning problem, and, you know, the cross-functional teams that you've put together with some really amazing people in them, and how everyone works together towards this one goal. I thought it was really inspiring, and something other utilities who are walking down that same journey are going to want to consider beyond just the machine learning piece here.
Yeah, a lot of change management going on here.
Yep. All right, so let's dive into the how are we doing it part. So we keep saying machine learning models, but what does it actually mean? So let me start super high level and just talk about what machine learning is. So machine learning, and then explain like I'm five sort of way, is essentially teaching an algorithm to make prediction about the future by feeding it a ton of historical data to learn from. So we have all of this data about historical storms stretching years and years back, and we're asking these models to look through all of that data and essentially identify these patterns that say, at the beginning of the storm, when you're seeing this pattern of data, you can estimate that it's going to take, this long. And now machine learning and AI, they've become kind of buzzwords and umbrella terms. And so there are different types of models when it comes to machine learning. There are models that are just pure linear regression. There are decision trees. There are deep neural networks. Recently, there is more generative AI, ChatGPT type models as well. And so different models have different strengths and weaknesses. For example, deep neural networks can make connections that are really what we call high order associations, things that they can recognize are connected that a human brain might just not be able to do. And so they are really, really powerful models. But the other thing about those neural networks is that they are complete black boxes, and there are very smart people working on the black box problem. But the problem is that when you're using a neural network to do something like ETR predictions or prioritize who's going to get their power restored next, you want to be able to explain why you made that prediction or why you made that decision. And deep neural networks are not really good for that. Tree-based models are still very powerful, but they're just not as potentially powerful as neural networks, for example. But unlike those neural nets, these tree-based models are fully auditable, which means that you can do, more or less explain why the model made a certain decision or a prediction, which is just something that's important when you're operating in a highly regulated environment like DTE and other utilities are. And, if I were to talk about which type of model did we go with, there's another type-ish of models in machine learning, and they are called ensemble models, which essentially means it's a group of different models working together to make a better prediction. So they all sort of vote on what they think, the most accurate ETR is, and we choose by some method that ETR, sort of by taking an average or by taking a vote. And that's something that ended up being really, really important when we were developing these models with DTE, and I'll explain why in a second. So let's dive into our model, and let's start with some of the challenges that we faced from a machine learning perspective. So the first challenge, and again, one of the hardest things about developing these models is this tension. We sort of mentioned it through slightly different lens before, when we were talking about overestimating and underestimating. There is this tension between accuracy and timeliness, right? So let's take these to the very extreme. On one end, when a lot of time has already passed and the storm is over, so we are in the future, the storm is done, we know exactly how long it took us to restore each customer because it already happened and it's recorded history. But it's not very useful for telling people how long it's going to take because it already happened. On the very opposite end of that spectrum, when the storm is just beginning, nothing has happened yet, and we don't have a ton of information to work with. So we can make some guesses, but in the extreme case, we do have weather forecasting predictions. So if I take it back even more extreme and I say, let's predict outage restoration times in 2 months from now, when we don't exactly know what the weather is going to be like, we don't have any information that'll help us do that. So as the storm starts and as it goes on, more and more data becomes available. And so, these models have more data to work with and can provide more accurate estimates. And so something that we did together with DTE when we started building these models is essentially this experiment to take a look at the existing models and some of the prototypes that we had and essentially measure how accurate they were every hour or time interval into the storm. And what we found was that 1 hour in, there was a huge jump in model performance and accuracy. And we actually found that 1 hour into the storm is more or less that sweet spot, at least for DTE. You'll see how different utilities are different regions are different, but at least for DTE, waiting 1 hour into the storm gives us enough data to make these models really accurate. And we could wait the full 4 hours that we give ourselves in terms of what customers are expecting, but really it's marginal accuracy improvements at that point. So how do we balance accuracy, and how early can we notify a customer with an ETR? We sort of talked about the 30 minutes in blue sky, 4 hours in storm conditions. And so for now, we've decided on this 1 hour threshold for when we feel comfortable enough with the predictions of these models. Now, the second challenge from a machine learning perspective, and this goes back to the change management and all the process that goes into actual restoration work. It's a complicated process. It varies between utilities. And so, Jackie, you mentioned this just a little bit, but maybe to illustrate, you can talk about how there are some, classifications of different customers and how the restoration strategy, not the restoration estimation strategy, but the restoration strategy itself might change based on the kind of customer that we're talking about.
Yeah, absolutely. So you got here the, hospitals, some government agencies, and sometimes it kind of depends upon when the storm is too, right? So for example, our last storm, the Rocket Mortgage Classic golf outing was happening in the city of Detroit, right? And they had an outage from the storm. So that would be a huge, not just, inconvenience for that, for the golf event, but like, a reputational risk from DT's perspective. We've had times where, like the last weekend, it was the Ann Arbor Art Fair, another big event that happens. So we, take into account, safety, hospitals, things like that, any special events that are taking place, could be even a concert at the Little Caesars Arena. If it, we want to make sure that they have power. And then we start to really prioritize really large outages and, kind of whittle our way down to try to get as many people back as fast as possible. And what's really important that we're bringing this up is that what you're hitting on right now is the estimate strategy has to match that pattern of restoration. So we can't just go build a daily plan, which is, what we build during a storm to say, like, this is the order of restoration. Can't build a daily plan without like informing the estimates and back and forth, right? They have to go hand in hand.
Yeah. And, this is something that I really appreciated when we started this project. You let us sit in on some of those daily plan restoration calls where the restoration team gets together and really walks through this very robust, well-defined process of, number one, we're going to see, how many wire downs, and number two, we're going to see how many hospitals were affected, and number three, and I realized that as we were going through all of that, there are different ways that you could do it, right? And in fact, I think DTE itself has changed that kind of daily plan template in the last 2 years. So, we're teaching this machine to predict how long it's going to take us to restore, but, we're using data from times that, the restoration strategy might have been a little bit different, and the restoration strategy might still change in the future. So one of those challenges from a machine learning perspective, and it's almost what we call machine learning ops, is that these models have to be in sync with the kind of strategy that the utility has implemented, and they also have to be able to adapt to changes in strategy moving forward, not to mention, evolving climate patterns and improved infrastructure. So, one thing that we built into these models is a strategy. One of the things that we're building into these models moving forward is this idea that they'll be able to monitor their own performance. And as these things start to change, as the economic landscape, as the infrastructure changes, as climate change does its thing, or a change in strategy, these models will know that that something has changed because model performance is down, and they'll be able to retrain themselves if they can, to increase their accuracy to where we want them to be, and otherwise to at least alert a human and say, hey, we're seeing these changes in model performance and you guys should know about it. So, two big challenges, and by no means that the last challenges that we face, but some of the big ones that I wanted to highlight. And so as we were working through all of this, all of these different models, one thing became very, very clear, and it was that these models really have to be personalized for the utility, because of what we just discussed in terms of restoration strategy. They also have to be very specific to your region, because even things like subtle local weather patterns can have a massive impact on restoration times. And so they depend on all of these different operational things: the weather, location, the time of day that the storm is happening, the day in the week that the storm is happening. And like we mentioned, those customer expectations: do you have 4 hours? Do you have 2 hours? How do we do this in a way that really optimizes for accuracy and timeliness, but how do we also make sure that it matches with our specific customer base's expectations? And, I talked earlier about the fact that this model is really just, is actually a group of models. And this group of models actually breaks down into 3 categories. And so we've got models for blue sky conditions, we've got models for storm conditions, and we've got a different model for catastrophic storms, because each one of these environments is so different that the models have to learn entirely different sets of associations in order to perform well. And even within these models, there are additional groups of models that take care of different times of day, different days of the week, those kinds of things. But I'm curious, Jackie, maybe just anecdotally, how have you seen these different type of outages and different types of conditions? How different is it really when it comes to being on the ground and restoring everyone's power?
By the way, that the graphic on the right-hand side just scares me when I look at it.
Do you like it? People here loved it, so we opted to keep it.
Yeah, it actually, so blue sky day, I mean, our teams are prepared for that. That's what they do every single day, right? So the service centers get the people out at the door, get them on job. So it's a pretty known condition for us, right? That's what we do. And unfortunately, for DTE, we have a really old grid, and we're doing a lot of investment in it, but frankly, we do have a higher proportion of outages than many of our peers. So, and as far as our estimates for blue sky, again, we're pretty good. I think we definitely can improve, but we've got a lot of historical data. So okay there. Storm, and this is almost maybe this is maybe the sweet spot, because we have catastrophic, you have maybe 1 or 2 a year. Some years we do have more, but you have a couple a year. You get a little bit more grace from your customers when they, if there's a tornado that's gone through and everything. But both of them. So storm model, super important to us to be able to get good estimates out. We have probably 10 of these a year. So the CEO recently has been describing, we have like 20 days a year that are bad, and that pretty much dictates how our customers are going to think of us for the rest of the year and in everything else we do. So of those 20 days, right, or 21 days, whatever it really is, we really need to be accurate with getting out information for our customers. So the different storm models are super important. I think catastrophic storm model, again, that's where these can take like a week for restoration for us. So important to get good data out to our customers for those as well. Did I hit on the points you wanted me to hit there? I wasn't.
So.
Okay.
Yeah, I've got some more.
Okay.
So yeah, clearly all of these types of storms require, different type of work on the ground and therefore require different models. What we found that was difficult from a machine learning perspective is because catastrophic storms, each catastrophic storm is so different than the others, right? It's a completely unique situation. So, it's harder to learn these patterns in the first place, not to mention because you only have 1 or 2 of those a year, there's a lot less training data to work with compared to the more regular storms. And I think even for the regular storms that you told me, you've seen one storm,
Yeah, exactly. I think one of my peers used to work in the airport industry, and he made the funny comment, if you've seen one airport, you've seen one airport, which I thought was hilarious because it just, and then I thought the same really applies to each storm. If you've seen one storm, you've seen one storm. Same with catastrophic, it's even more pronounced there. Just an aside too, one of my peers is training to like work in storm. And she said, well, we've got A, B, C, D all locked down, Jackie. We've improved the processes around that. What am I going to do? And I said, I can't tell you now, but we'll find out in a couple hours. But there's always something that happens. So yeah, yes, if you've seen one storm, you've seen one storm.
Yep.
Now, yeah.
Cool. So let's take a deeper look at some of the data that ended up being fed into this model. And of course, it's very high level, but weather data and weather forecasts ended up being a huge part of model performance. Information about the crew, how many crews do we have available, where are they, how many other jobs are open, time of day and day of week also mattered a lot, because storms behave differently at different times of day. And of course, when we lose daylight, that changes, the math for DTE. And then of course, day of the week, weekend versus weekday also has a huge impact on customer expectations, not to mention, weekend working hours versus weekday working hours. So lots of things ended up being important there. And then of course, the infrastructure itself, which circuit are we on, what level is the outage at, all ended up being very significant. And something that I thought would be interesting to share, with everyone who's watching. And, this is just for one of the models that we built as an example, but from a technical perspective, these models, you're able to pull out what these are called Shapley values that essentially tell you how important are different data points to the model's predictive accuracy, and which way are they influencing the prediction? Is it like higher or lower? But I think, in order to really get the gist of this slide, the things at the top are more predictive than the things at the bottom. We're still looking at the top predictive attributes from dozens and dozens and dozens of attributes. But I did think it was really interesting to show that at the very top of this model, we've got all the weather, attributes like temperature, pressure, thunder, wind, and these all were very easily at the top in terms of predictive power. Then we're getting into some more operational stuff like above ground line miles, number of customers that are out, open wire downs, and all of these things. So, just wanted to share some insights into not just the data that we used for these models, but how that data ended up being more or less useful. And of course, if you just give it the weather, you're not going to have very accurate ETRs, but together, all of these things come together to make these, a lot more accurate ETRs. And that's why we're on the path to where we want to be with ETR accuracy. Now, one of our models takes ETR predictions to the next level and breaks things down into two parts. And it's just a strategy that I wanted to share with some of the more technical folks on the call, just because, it ended up being a useful technique here. So this particular model breaks things into two parts. First, it predicts the time it will take for a crew to arrive at a particular job. And second, it'll predict the time that it takes the crew to complete the job. So we have some models that are just trained at the entire ETR, and we've got this model that breaks it into two parts. And specifically, in order to do this, we used a technique called entity embeddings to take this kind of time series data and flatten it so that our machine learning models can understand it. And with entity embeddings, we can essentially map these meters, these feeders, these transformers, and really understand how the machines behave as part of, these restoration efforts, how, this machine is similar to this machine, which ones are vulnerable to ice or thunder events, which regions in our territory and which substations are more vulnerable. So, this was a really interesting piece of the model development. And we did notice that this particular two-part model does have higher accuracy than some of its siblings in that ensemble, but it does take more resources to run in real time, and it requires more data to be able to provide this kind of accuracy. So it's used in very specific instances where the other models are less confident. But I did want to share this technique because it ended up being a really effective part of our machine learning strategy. And then, Jackie, I was hoping we can also, as we continue towards wrapping this up, maybe talk about, once we have these ETRs, what do we actually do with them? What are the communication strategies that we have to make sure that we are not just, a while back, someone once told me, your data is very interesting and educational. That was like 7 years ago when we just started BlastPoint. And I made it my life's mission to never hear those words again, because I don't care if it's interesting. I want it to be impactful. So let's talk about how we actually take these ETRs and get them to our customers and make sure that that impact on satisfaction and loyalty and reliability is there.
Yeah, Chartwell has done a lot of research and it lines up with what we have seen from our customers as well, that in the past, we used to do a lot more like actual phone calls out. But now we know that customers almost primarily want to get a text message with their ETR. And so that's our text and email are our primary channels that we're using to get information out. Really relying more on the text side of things, because I have heard several times, and it's been even, employees where email is where we sent something and, people, it's, buried in their Yahoo email or something like that. So we're relying more and more on text. We did choose through the error-free communication program to auto-enroll all of our customers into this type of messaging as well. Slightly controversial kind of topic, utilities talk about it all the time. But yeah, we chose, if we have your contact information, we're going to send you a message when you're out or your estimate and you're restored. And again, it was a little bit controversial when we said we were going to enroll everybody. And I don't think we've had like 0 complaints or negative feedback about doing that. I think people kind of assume that you're going to tell them. So yeah, that's what we rely on. Text and email. There are a few phone calls potentially that go out, but that's what we rely on. And that's what we hear from our customers. That's the way they want to be communicated to.
Yeah, I think the opt-in strategy was really interesting, and I could see how it would be controversial on one hand, but also completely expected at the same time. So I think that's a really important thing to highlight. And yeah, the other thing that I think is important when you are serving a territory that has catastrophic storms or other kinds of potential natural disasters, having contact information for as many of your customers as possible is also really, really important. It's something that we help some of our utility partners do as well, finding phone numbers, emails, or even just getting customers who we think can supply their emails or phone numbers engaged through other means, since we don't have their email or phone number, and get those contact information rates up. So really important. And I think, just to underscore the end of our presentation today with, it's not just about the machine learning, it's about what you do with it. And so, with that brings us to the end of our presentation. Jackie, thank you so much for taking the time and sharing the experience, the expertise. We were scheduled for 45 minutes. We're well above that now. We did get a few questions during this. So what we'll do is we will answer them all and send them out as part of a post-webinar email. But thank you all for taking the time and watching this webinar. Jackie, again, any last words before we depart?
Oh, it's been an absolute pleasure working with BlastPoint. You guys have been doing some amazing work, and I'm looking forward to continue work with you.
Absolutely. Well, thank you very much. Please let us know if you have any more questions. We'll try to get as many answered as possible before we send out that email, and have an amazing rest of your day. Thank you very much. Have a good, whatever day it is. Bye.
Thank you.